Welcome again, everyone. I'm Michael Gregory.
I'm Kalina Dimitrova.
And welcome to AIMLOW, Artificial Intelligence and Machine Learning Online Workshops. So thank you for joining us. This is our first session today. Like expected, we'll go over some introductions, expectations, and where we're going with the course. A number of you already joined us for the Scientix webinar last week. If you didn't, no worries. This is completely independent, the start of the course, but you will see a couple of familiar things as we start off the course. Anything to say before we introduce ourselves?
Well, I say we just wait a minute or two because we have some people joining us right now as we speak.
Okay, well, and I guess a couple of things to mention. So as we mentioned in the email, you'll be encouraged to participate, at times to use your cameras and microphones. Yeah. Feel free to have them off at any time we don't say, okay, now we want you to discuss something. But anytime you have a question, feel free to interrupt us. Most of you know my background is from teaching. So like a lot of you, I'm interested in being, I'm used to being interrupted, not bothered by it at all. So anytime you have something to interrupt or say, then please feel free.
Yes, for the ones who are not comfortable using their microphones and cameras, please use the chat. We are looking at the chat at all times. So however you feel like. So.
Okay, so I think I'll start introducing myself.
Okay, yes.
Okay. You're worried about people who come late, but the people who come late, they'll already know me or they don't care. So for those of you who don't know me yet, my background is in teaching science, about a decade and a half experience doing that. My current job, which is what put me here, learning about artificial intelligence and sharing what I'm learning with you guys, is at the European Physical Society, which is still France. So I left Paris, but didn't go that far. And there I'm the new EU project officer for Discovery Space, which is an EU-funded project. I'll be telling you a lot more about it as this course goes on. One of the aspects of Discovery Space is using the power of artificial intelligence to guide students through differentiated learning pathways. So it's very related to AI, but this course, of course, goes into a lot more detail about AI than some of the other Discovery Space stuff. And Kalina, how about yourself?
So yeah, I am actually from a very different background than Michael, although I am slightly related to teaching in the sense that I have taught students a lot. I am actually a scientist and I am currently a PhD student in particle physics at Sofia University in Bulgaria. So it was a long journey to come here, and I have gone through studying astrophysics. I've also have a degree in geophysics, but yeah, that's another story. My main field of work is indeed particle physics, and the thing that I do is data reconstruction and analysis for several experiments in different laboratories. So most of you probably assume and know about the European Center for Nuclear Research, also CERN. So I work for one of the experiments there. And also maybe my more main work and main experiment is called PADME. And it is located in Italy, in Frascati, which is right next to Rome. And it's a very, very interesting small dark matter experiment. So I'm kind of a dark matter hunter. And for that reason, actually, my main topic is the development of AI methods for data analysis. So what I do on a daily basis is tackle large amounts of code in order to try and train AI to see particle physics data and find new exciting information about particles, very different methods, very different techniques. And one of my main interests is actually AI explainability. So I don't only want to write AI, I also want to see how exactly the algorithms that I write are, let's say, how they perform, how they make the decisions that they make. So yeah, that's basically for me. And as I have finished this slide with, I'm also interested in and eager to spread science communication and teaching because it's been my passion for the last couple of years and it still continues to be.
and so the bottom line for both of us, in case you didn't get it through what we were saying, is I'm an expert in teaching and science teaching, and Kalina is an expert in artificial intelligence. So we've teamed up together joining forces to bring you AIMLOW. Oh, yeah, that's the right slide.
Yes, basically the idea for this whole course started a few months ago when Michael reached out to me and said, oh, I remember when I met you last year, which is actually the picture in the middle. When I met you last year, you mentioned that you work on AI, so I'm interested in developing AI tools for teaching, and yeah, can you help me or something like that? I don't remember what you said.
Yeah, that's pretty much it. Yeah.
So yeah, we came up with the idea of joining forces and developing this course with his expertise in teaching, my knowledge of artificial intelligence, and to try and teach people new exciting things about AI and how they can harness the power of AI into their classrooms. Or if we should go in that direction, learn to recognize when AI is used or misused by students and so on. So this is a lot of the things that we aim to cover in this course, actually, and many, many more. You will see them. But yeah, this is basically Michael and me and how we came together to present to you what you're about to see.
And it's wonderful seeing in the chat some of you saying hello as well and saying where you're joining from. I forgot to ask at the beginning for you guys to do that. But if you haven't done so already, it's exciting both for us to see where everyone's joining from and hopefully for you guys too to see some of the other people who are on this course. A little bit later on, well, actually, in preparation for next time, we'll be asking you a little bit more about yourselves for anyone who's comfortable sharing that. But already just to start, where you're joining us from is a great starting point. Also, I recognize a lot of people who joined me for particle physics for teachers last year. So it's great to see you guys again. We see staying in the theme of particle physics, even though I've diverged significantly from that with my current career path or what I'm doing, still a little bit of a connection there.
It all leads back to particle physics and you know it. Yes, good. So I think we are ready to start. And those of you who joined us for like the previous webinars or seminars, we already asked you that question. So now we are asking everyone once again, what is the first thing that comes to your mind when you think about artificial intelligence?
But we're doing it that in a slightly more pedagogical or like teacher way using a word cloud. So there's a link to a word cloud, but of course you probably won't feel like typing the whole link yourself. So we're going to add that into the chat. Kalina will do it as oh, excellent. People are already scared. 2 people are already scared artificial intelligence is taking our jobs. And when you think of something else, so if once you click on that link, you should get this same web page I'm typing here. And here I'll just type AI, which is the abbreviation for artificial intelligence. And we'll see it should, after it thinks about that, add that to the, added it to the word cloud there. So take a couple, well, take a minute or so and just add some of the things that come to your mind. If you, what?
Just repeat, click the link and type in the field the first thing that comes to your mind. What's the first thing that comes to your mind, Michael?
First thing that comes to my mind, AIMLOW, of course. So I'm going to add that onto there.
Okay.
Oh, and it took a while to refresh. I was worried people weren't doing it, but okay. And let's just wait for a couple more answers. If you're on it and you think of more than one thing, add another, because we'll see the size will change if people write the same thing. And I'm realizing taking our jobs, we wrote that when testing it ahead of time, which is why it's written twice and is written bigger than anything else.
Can you refresh it once more, please?
I'll refresh it by typing AIMLOW again, because I'm hoping AIMLOW comes out big there. It took AIMLOW isn't even on there anymore?
Well, no. Okay, but we still have some very, very good good suggestions. I see that someone typed tells lie.
Yeah, which it does lie. And when we look at text generation, we'll be looking at some of the reasons why text generation might come up with things that are untrue, or which sometimes I would call lies. I've even had whole conversations with ChatGPT that I've said like, "Why are you lying to me?" and calling it out on lying. I'll refresh this.
Yeah.
Oh yeah,
Oh,
okay. Tell us lies comes up.
Yeah, please refresh that so that we can all see it, because I'm already seeing it on my computer. And I think we have some a pretty big amount of answers.
Mm.
So we see that at the same time we have tells lie and lifesaver. Yeah. So you want to talk a little bit about these? Because we can actually, I see my favorite one. I see someone put in ChatGPT.
Ah, well, we'll talk a fair bit about that, but I think this is good like as a primer to know kind of what we're expecting, and then we'll use some of these when we go into our expectations.
Yes,
right?
indeed. So just a little bit, a few more things that I want to say about this is that we see that some people actually like put here examples of different AI tools, so different ways that artificial intelligence comes into our lives. And then we also have some misconceptions or something like that about AI, or some characteristics of AI, how it's a practical thing, it's more intelligent and so on. So yeah, good one. And I'm very, very happy to see that ChatGPT is on that a lot, because I am one of the people who stand by this idea that ChatGPT is, I don't know how it stands across the world, but at least, for example, here in Bulgaria, when I tell someone about artificial intelligence, the first thing that comes in the conversation is, oh, ChatGPT. So we have a whole dedicated session on language models, which is actually the next one, and we'll dive deeper into this. So yeah, good, very good to see all of your ideas. So how about we actually skip to the overview of this course?
And hopefully, can you check the
Yes.
Zoom so we see if it works?
Yes, it does.
Okay, yeah, it's back on the slides. Perfect. Where did I go? Okay. So we also wanted to go over some of the expectations. You'll remember when you signed up, we asked you, I forget the wording. Did we ask what you expect, or what
No.
do you hope to?
I think it was a more general question about tell us what you want to know about AI and something like that.
I think it was what you hope to learn.
Maybe.
Okay.
Let's go.
We forget the exact wording, but anyways, we took some of the like key or representative expectations for what some of you hope to get out of this course. Hopefully we'll address most, if not all of them. Your needs and expectations may evolve as things go on. Not only is it a quickly changing topic, but as you learn more, you kind of realize other things you want to learn. So we'll try and keep in mind where you guys are coming from, what you're interested in, and adapt as we go along. Although we do have a lot of things that we have in mind that we want to cover as well.
So this is the moment when I once again urge you, any questions you have, anything that you want to share or ask us or are wondering about, please feel free to write it in the chat right now. We are looking at that. Write emails to us, even like between the sessions and so on. If you come up with something, we're right here, and we're ready to include things in the next sessions as we go. So this is really a course that's for teachers, but it's also made by teachers, because we want to be as useful as possible to people. So it really comes to what you are eager to know about. And yeah, this is some of the things that actually people expect, at least they expect it when they fill the form. So a lot of teachers want to know how AI can help them, and yeah, people in general, but can help teachers in their teaching, like with different tools. And we will cover that. Also, a lot of people want to know how they want to recognize AI. So we see how we want to use artificial intelligence to help us, but we also want to know when someone else has used it to help themselves. Yeah.
And which is both in life in general, as well. One example I'll give at the end of today's session, but especially in a teaching setting, rules and guidelines and how text generation is used varies enormously from school to school, from country to country, because it's new and we're all trying to figure out what to do with it. But that's a question that comes up time and time again with teachers, no matter where. It's, how do I know if my students are using it? Is it bad they're using it? How should they use it? What do I do if they use it? Should I use it? A lot of things like that as well.
Yeah, so I am very happy to see that actually most of the things are quite positive, and people are not afraid to employ AI methods in their teaching and in their everyday life, which is amazing because there is a lot of misconceptions spreading about artificial intelligence taking our jobs or something like that. So this is not the case. So should we move on?
Oh yeah. So some of you are also expecting or hoping to get course certificates at the end of the course, which will be at the end of all the sessions if you've attended at least 5 of the 6 and done some of the homework we assign in between. If you're only interested in coming from time to time, that's perfectly okay. Most of the sessions should be semi-independent. So say, for example, you don't care about text generation, but you're really interested in the image stuff, skip next week and come the next time. But if you're interested in a completion certificate, you need to complete most of the course. For that reason, and that reason alone, we have an attendance form. So if you want to be marked as present and receive a completion certificate, take a moment to go to the form. Did we copy it in the chat yet?
Not yet.
No. Okay,
but
so
give me 1 second and
so it'll be in the chat in a sec. You don't really need to be shown what the form looks like. It's a form to enter your email and your name. Obviously, use like as the form says, use the same ones you use to sign up. If you have 10 different email addresses and you use a different one every time you sign up, I probably won't have patience to sort through it, and you'll just be marked as not being here. So if you're interested in that, fill that out. That shouldn't take much cognitive attention. So we'll continue talking about other things while those interested do that.
Yeah.
And we get to the part where we're looking at terminology and vocabulary.
Yes. So I promise this won't be the most boring part, but since we are going to talk about artificial intelligence and everything that lies behind that for the next week, it's good to have at least like a general understanding of the most important AI terms. And this is good for the course, but I also believe it will be very useful to teachers. Doesn't matter if you're like a physics teacher or you're informatics teacher or something like computer science. I believe that artificial intelligence will come into lessons more and more often. So with this little part of the course, I really want to help people form a better understanding about some of the terms that come very, very often, basically every day, especially for people interested in technology. So yeah, I really hope to be useful to you. And yeah, something that even Michael doesn't know, and he's about to find out right now. So because this is going to be something like a lesson from me, but I hope that all of you really get involved, answer the questions and so on. I want to include Michael to you because yeah.
I'm perfectly fine with being put on the spot. I fully admitted, or maybe I forgot to admit that like I'm learning as we go as well. So with like when I started my new job at EPS, I didn't know anything about artificial intelligence. So I sought out some of the best people in the world, especially Kalina. And so as I'm learning, then I'm sharing forwards with you guys. But I'm not the AI expert, I'm the teaching expert. So yeah, put me on the spot. That's okay. If it's for educational purposes, embarrass me as much as you want.
So yeah, I will need you also to include some answers on the questions that I ask. Because we are in a Zoom meeting. There are a lot of people here. I'm very happy to see so many people, but also it's good to have someone in front of me to tell me if the things that I'm explaining are like way off somewhere or that everything is understandable. So yes, I want to start this actually with a little bit of let's say survey. Although we're not going to use any links or anything, we're just going to use the chat, or maybe if someone wants to turn on their microphone and say.
Well, we eventually use links, but
no, not for this slide though. So there are a few terms that people often like misuse. I have put this here: artificial intelligence, machine learning, neural networks, training models. So if someone wants to turn on their microphone now, and please tell us what do you understand when you hear artificial intelligence. So if you say are in front of the students and you want to explain to them the term AI, what would you say? And you could also write that in the chat if you want to. And to kick this off, Michael, if you were teaching and you had to explain the term artificial intelligence to a class of students, what would you tell them?
10-second explanation, 1-minute explanation, or whole class explanation?
Let's keep it to 10-second to 1-minute explanation.
Okay, so how would I explain artificial intelligence to a class? Artificial intelligence is an age-old concept that's become more and more popular recently as computing power has enabled it to be more powerful and user-friendly, and it attempts to use the power of computers and computation to make connections and output in ways similar to humans would be. Yeah, human mimicry, using computations to mimic human output for a given input.
Using computations to mimic human output. And here we have another answer in the chat that says, I always say them, it will be smart as you are, dear kids. I don't know, maybe, probably, maybe not actually, because artificial intelligence, although it's developing, it's quite a vast topic, and it becoming smarter than humans is a quite sensitive topic. But let's see, not quite an intelligence right now, but a computational development that mimics human, but is able to be trained very, very well. It collects all of our experience, yes. Big database, creating sentences where a link is between question and topic, creating sentences by probability. Awesome, yes. Basically, when we talk about artificial intelligence, as the name suggests, we want to mimic something we already have in humans. So let's move forward to machine learning. Now we're getting into like more and more specific terms, I guess. But it's interesting that many people talk about machine learning and label it as artificial intelligence, maybe like to sound more modern or something like that. And I myself am guilty of that. So we here see that someone says, in order to simplify their work and evolve faster, humans have created patterns based on cumulative databases. Yes, very good. So yeah, all of the answers generally like revolve around the idea that artificial intelligence mimics humans. And we have this topic of the big database, which is actually something that's quite, let's say, better for artificial intelligence than us, because computers can process much more information than we can in much smaller amounts of time. So let's move to machine learning, though, because machine learning is a type of artificial intelligence. But it's interesting that it's been around for a big amount of time now, maybe like a couple decades. And for artificial intelligence, we've only been talking so much in the past couple years, and people have been doing machine learning for a lot of time. So machine learning versus artificial intelligence.
So I'm on the spot again?
Well,
no, I can be, but at the same time, people should be thinking of it themselves and putting it in the chat, and not just copying my answer, because it's probably wrong anyways. So I would say machine learning is an iterative process where there is some kind of feedback used to change the algorithm or process that's being used for computation. Yeah, and actually to move on with this, because we have a couple more terms, I've put here neural networks too. And actually the whole idea behind this few words that I have put here is that machine learning is a type of artificial intelligence, and neural networks are a type of machine learning. And training and models, those are now very specific terms.
So I actually want to see in the chat if someone wants to share, or if someone wants to unmute themselves also, this is perfectly fine. What do you think about when you hear about training artificial intelligence? How would you explain training? So result of training in comparing characteristics. Yes, this is actually what we are going to show in a minute. But recently, with the development of more and more artificial intelligence tools, people have been talking about something being trained on some data. So what exactly do we say when we say we train artificial intelligence? At least what comes to your mind? This is not a right or wrong question. This is more to see like what do people think. So you can also share what you think about training. I've shown you how we train many algorithms.
Well, so training from a user point of view or from a behind the scenes what it's doing?
From a user point of view, definitely.
Because from like from behind the scenes, it's, I mean, then it relates to a neural network. So it's creating nodes and then looking at the strength of connections or the probability of different pathways going, and then feeding that into a positive feedback loop where you'd be favoring the connections that were used more. But in terms of like a user point of view, it's that you get some information or data that you put in, and then you're expecting or hoping for output that reflects an average of what you put in.
If you look,
it's like a big averaging machine. It's like the ultimate bell curve.
If you look at the chat, because you weren't looking at the chat while talking about this, it's right there. Yes, precisely.
Oh, so thank you. Everyone gave me the answers.
Yeah. Okay, good. So yeah, for next part, can you change the slide? Yeah.
The slide, yeah.
So for the next couple of slides, I will go around the main terms that we talk about when we talk about artificial intelligence. So a little bit like a lesson, a little bit like a lecture, although I will try not to bore you very much. And in order not to bore you very much, I want you to participate in this. Again, with the link, which now Michael is pasting into the chat. So this is going to be another word cloud, and we need you.
And trust me, the course isn't just going to be word clouds. We have other tricks up our sleeve. At first I said, no, we're not going to do another word cloud right after the first one, but it just ended up how things work today. But like next time, we're probably not going to use any word clouds. No promises, but
no, it's a good thing. Okay. It's a good thing to collect answers.
Yeah. So you have the link in the chat again, and I'll. Well, I won't go to the word cloud yet because we'll look at it afterwards. Yeah. So just add to it as Kalina is going on and explaining things. And anytime there's something you think is a key term that we might want to define or have a common description or definition of, write into the word cloud, and hopefully we'll see a couple terms that come up as something she keeps saying.
Yeah.
Maybe even emphasize it, says twice to get things kicked off. And we'll see how it goes from there.
Yes. So to repeat once again, I will be telling you the fairy tale of artificial intelligence as we know it now, and keep your attention to the most important terms I mentioned. And when you feel that term is important, put it in the word cloud, because in the end we're going to make a little bit of a glossary of everything we have learned, and we're going to use that as something to refer to in the next sessions if at some point we forget about if we forget what something is about. So yeah.
Well, I just want to ask, should I also be typing into the word cloud so we have more entries? Because the word cloud is kind of like a microcosm for machine learning. The more data we put into it, the better our output is. Like the more of us who are typing in the keywords, the more we'll have different keywords that sort out as more important than others.
Okay, if you want to, you can do that too. So I guess I will be giving you this laptop and
Yeah, so we'll just do a switcheroo. You have enough battery power.
yes.
And good luck with that.
Thank you. All right. So yes, this is where we start a little bit with the terms. And just before I start, does anyone have any questions until this point? Anyone want to add something or something like that? Can you just please give me a look at the chat so that I can see if anyone has any questions? Otherwise, I'm beginning. Okay. So I don't see any questions, and you also feel free to unmute yourself and just interrupt me. But yes, basically, I want to start with a little bit of terminology about what is artificial intelligence, what is machine learning, and everything else. And actually, to the left here, what you see is a scheme, a diagram that I very much like, because the whole topic of artificial intelligence actually covers many different things, from what you see here that are terms from robotics. We can talk about computer vision, visual perception, different styles of programming, and so on. Everything can be embodied by the term artificial intelligence. So it's a very vast topic. And when we say that we include artificial intelligence, we actually do not say much, because this can be anything from putting a robot in a classroom and showing that to the students, to using some tool that analyzes data through machine learning algorithms or something like that, and many other things. So if we want to define artificial intelligence, this is indeed what everyone already said. This is mimicking human behaviors, human processes through computers and through machines. Nothing more. And now if you want to get more exact, we can go into the machine learning part, which is now defined by mathematical expressions, mathematical operations, and stuff like that. Different computer programs that can be written, different ways to make decisions, and so on with computer algorithms. So machine learning now refers to how we teach a computer to analyze, recognize data, and to make decisions based on that. And one maybe like the most used part of machine learning nowadays is actually neural networks. And in most of these courses, we will be showing you neural networks as the preferred type of machine learning. So as their name suggests, neural networks take the idea for the way a human brain works. So we want to see actually what happens in our brain when we need to process information. And I very much like to give this example, which is when we teach young children different things about the world around us. It's actually very similar to teach a child and to teach a computer, because in a computer, we just develop a system of nodes that's very, very similar to what we have in our brains. So the different neurons that we have in our brains, and they are connected with each other. This is exactly what we define in computers. Actually, here on the slide, I have just put some random schemes that I like. And in the upper right corner, you can see a simple neural network. And I'm going to use it to show you the similarities between a neural network and actual neurons in our brain. So what you see here are some numbers in some circles, and this is what we call the neurons in a neural network. And these would be also neurons in our brain that get activated through these nodes, which are the connections between the individual neurons. So this is the idea that scientists had, and it's an idea that has been around in for quite some years now. Actually, neural networks have been developed in the 80s, maybe in the 70s even. I'm not very sure of the exact time, but yeah, it's the most common type of machine learning. And there's also this thing called deep learning. So deep learning is nothing more than creating more and more complex models. When we create a neural network, we basically have information and what we want to take out of this information. And between this input and output, we have to define these neurons and the connections between them. Now, this can be a very, very complicated network with many different types of connections and so on. And the more complicated it is, the deeper we say it is, because these are connections that they are not something that makes sense if taken individually. In the end, we need to see the path between the input and the output and how it gets activated. And the harder the path is, the deeper the network is. So in a way, this is like this whole thing on the left. And in deep learning, you see different abbreviations, CNN, RNN, and so on. So CNN, for example, stands for convolutional neural network. RNN stands for recurrent neural network, and so on. And these are all different ways to define these nodes. And here I've also, I don't know if you can see my pointer, I really hope you can, but in the upper right scheme, the left part of it is something else, which is called a decision tree, which is another type of a machine learning algorithm. We're not going to cover much of these because they are quite, let's say they're for quite specific cases. So neural networks are basically the more used type of machine learning. And there's 3 types of machine learning, which is for me maybe my favorite part when I like to tell people about machine learning and artificial intelligence. And again, I want to make the analogy with teaching a child things about the world around them. So we can have supervised learning, we can have unsupervised learning, we can have reinforcement learning. These are the 3 types, and it's very important to make this, to distinct them. So when we have supervised learning, we have some information, some data, let's say images of things, some numbers or text or whatever. And then we have the truth about that information. So you're going to hear me say examples about dogs and cats quite a while. You're going to get sick of dogs and cats during this course, but this is maybe the best example that could be given. So supervised learning, think of it in the following way. You have images of dogs and cats, and for each image, you have information what is on that. That's why we call it supervised learning, because we know the universal truth about all of the data that we are filling in the neural network or
Yes.
the other machine learning algorithm. So those can be classification tasks, regression tasks. The main difference between them is that when you classify things, you just put them into categories. We're going to do that in one of the sessions, actually. We're going to classify images. Regression tasks, we get some information,
Yes.
numbers. So when we have unsupervised learning, we do not know the truth about the about the data that we are feeding the algorithm. As you can see,
Yes.
under the blue thing, it says model training with unlabeled data. So this means that we give the data, which would be maybe a sequence of numbers or a more complicated sequence of numbers that would be an image or something like that. And we just parse the data, and we want the algorithm to find patterns, to find motives, and in some way reproduce it. A very classic case of unsupervised learning is actually language models, text processing, and so on. Where you just have text generated based on a large number of sentences that were analyzed by some algorithm, and it just learns to replicate the data. The third thing is maybe like the most interesting and the most complex one, because it's reinforcement learning, where you have like trial and error. So you have something that propagates back and sees exactly how when the algorithm trains, the errors it makes, bring it back to the original point and adjust the algorithm itself. So if we want to compare this to teaching a child, this would mean that when we have supervised learning, we will be showing a child things around them, and we will be pointing them to this is this, this is that, this is another thing. And by repetition, we will eventually show them the things around. When we have unsupervised learning, we leave the child around the house and hope that it learns, for example, paths through different rooms and so on without really telling them anything. And reinforcement learning, that is maybe like the easiest thing when we talk about teaching children, because trial and error is the universal law. Don't touch the stove, it is hot, and then we touch it. So this is the main things that we have here. So I'm moving forward to the actual process of training a machine learning model. And we have developed a few neural networks that we're going to train together in the following sessions. So this is essentially what we will do, or we will tell a computer to do. Actually, the computer is 2 meters away from me right now. Yeah.
Do you want to show it?
No, I don't.
Okay.
I don't know if it will be seen very well, but if I move the camera a little bit and if people pay attention to the camera, if you see these things behind me, these racks, this is where, okay, Michael will show them. Yeah, this is.
That's an oscilloscope.
That's an oscilloscope, that's true, but this is where some of the computers that we will train neural networks are. So back to the training process.
That's also, there's multiple oscilloscopes.
Yes, there is. So back to the process of training. What we want to do with an algorithm. So imagine that we have some data and we want to create artificial intelligence, a machine learning algorithm, more specifically a neural network, that analyzes this data and, for example, categorizes things based on features in them. So what we first need is to get the data, and this is the most important and the hardest probably step in it, because algorithms are only as good as we construct them, and computers, they're not smart. They cannot spot errors that we have unintentionally made. So we need to get the data, and this step 2 that you see in purple here is quite important. We need to clean it, prepare it, and manipulate it in order that the computer sees everything nice and neat, and there are no fundamental differences in the different instances of the data that we're passing to it. So once that we, for ourselves and for the computer, know how the data that we want to train looks like, we need to define a model. So this is the actual way that the neural network will look like. This is the mathematical operations that will be performed on this data that was cleaned, prepared, and manipulated in order to extract from it the features that will help the computer make the decision. So then we need to train the algorithm and test it on another data. So basically, if we want to see if a student has only learned by heart the material, we can just ask them the same questions. But if we want to see if they had understood how to solve the problems, we give them different problems. And that's what we do with the computer too. We give them independent instances of the data, ones that they have not been trained on, and see how good the algorithm will perform on those. And then we improve and we go back and we iterate and iterate and iterate over this until we are happy. So this is the process, and I really want to put an emphasis on preparing the data and the output, because as I said, and I'm going to repeat it once again, computers are not that smart. They cannot spot inconsistencies. They need everything to be the same in order to be able to parse it. For example, if we want to train a neural network on images, and we all take images with our phones and give it to the network, it will go crazy and just give us errors. Why? Because our phones are different. They produce images with different quality, different sizes, and so on. And computers don't like that. They want everything to be the same and uniform. So the input data should really be prepared, and really we should know that it is in a nice and neat way. And when we talk about input data, we can have different types. For example, it can be one-dimensional. That would be text, which is just sentences with words which are parsed as numbers and so on. It can be a waveform, for example. What I deal with is waveforms that come from different detectors, but they are basically things that just look like this. For example, earthquakes too. If you have a seismogram of an earthquake, this is a good example of one-dimensional data. Basically, any time series, any graph that shows you how something changes with time is one-dimensional data.
Well, time is the second dimension.
Yes, but still we don't count that because everything is just an array of numbers.
Okay.
So two-dimensional data, that would be images, the more classic case, and everything can be really viewed as an image if it is in 2D. But we can have like 3D, we can have even more dimensional data, but the more dimensions we add, the more complex the model becomes. And what is more interest is that if we have a desired output, so we have supervised learning, we need to really give thoughts into how exactly would that look like. So what you see, for example, here at this image, I don't know, I think you can, okay, yes, you can see my cursor. We have an instance of a neural network here, and we have some input data, which can be the pixel values from an image. And then as the output, we have two numbers. And these could be, for example, two categories that we want to put this image into, one or the other. But my whole idea is that as much as the input is important, the way the output looks, the output data, the desired output, however you want to call it, the output is even more important. And this is actually the hardest thing of all when you want to design artificial intelligence, to see what exactly do you want at the end and what exactly do you want this algorithm to lead you to. So yes, input is important, it has to be right, but output is even more important. So once we have prepared that, we actually, you see a lot of things on this slide, but they're just examples of different ways you can construct an algorithm. So once we have prepared the input and the output, we want to define the model that connects the two. We want to create the brain, basically. And you can do it in many, many ways. So on the right part of this slide, you can see a mostly complete chart of neural networks, which is many, many different types of architectures and ways to construct these neurons and nodes so that they connect the input and the output. For example, if I were to look at this, I would instantly tell you that this thing that I'm pointing to you, and it's labeled as Deep Convolutional Inversed Graphics Network. This is what I use, for example, in my particle data. So yeah, just a second, because I lost my slide. And yeah, sorry. Okay, I'm back. And
at least there's not much on that slide.
Yes. So different people use these different things. I really don't need anyone to remember all of these instances, but just you can see how vast a field this is. And this is all a different type of mathematical operations that can be defined in order to connect things between the different levels. Because what happens in a neural network is that we get the data, see the image of the zebra, for example, here. We have the desired output, which is the algorithm to tell us that we have a zebra, as you see it here. And we want the computer to make the connection. And it really does make the connection through different mathematical operations. What you see here, for example, is convolution. It is one type of a layer in a neural network where we have different weights and nodes going across the image, forming the output, and so on. If someone is interested more into how those different layers work, you can tell us so that we prepare something deeper into each type of layer. So for now, I don't want to go into all of the individual ways you can treat the data in neural networks. What's more important is to see how this here is one level, this here is one level, another level, and so on and so on. So this is a very, very deep neural network. This is, oh, sorry. This is, again, a type of deep learning. And for example, here, this one that I have included, it's very interesting because it's a very complex type of layer, which we have used when constructing the algorithm for our text processing tool. So in the next session, you will get to use a text processing tool, and it's one that we developed, and it uses such kind of complex mathematical operation layers, which are called long short-term memories. Long short-term memory, it's quite interesting. But then you have simpler ones where just on the next level, all the data points, all of the neurons are connected to all of the ones on the next level. And yeah, this is the more common type of neural networks anyway. But people have been developing more and more complex ones. So moving forward and not backward, I'm coming to an end of my little glossary of all of the terms with the idea of training and testing the model. So, okay, we have defined this architecture, which looks like some of these things, anything we want, anything we need. But we have now to train it. And the idea is as follows. Let's take again teaching a child. The ones of you who have listened to me present about this before may have heard this example, but I hope to many people it is new and it is quite explanatory. So take a child, a very, very small child that is yet starting to learn about animals. And you show them a couple pictures, a picture of a dog, a picture of a cat, a horse, a cow, a rabbit. And you show them the pictures only once. So show each individual picture, then show them another picture of a dog and want from them to say what type of animal is that. Oh, there's a good chance they will mislabel the animal because they've only seen the pictures once and they haven't had time to remember what's on them. Okay, but then let's show them the pictures 5 times. You all know that that will make for quite a bigger chance of another picture to be labeled correctly. If you show the child those pictures every day for a month, in the end, they will know what a dog, a cat, a horse, a cow, and a rabbit is. This is what you do when you train a model. Training the model means how many times do you show the data to the algorithm that you developed on the next step so that it can make the connections. And each time it makes the connections again, it makes them better, it iterates, and in a way sees which nodes and which connections are stronger and which ones are weaker. And if you do that enough times, it will eventually find the patterns. So the stronger nodes will define the patterns. This is what we mean by training. And training is always done simultaneously with testing. So for example, when I train neural networks, I always divide the data. I use 80% of the data for training and for showing the pictures of the child, the pictures to the child. And then I take 20% of the data, so a little bit of the remaining pictures, and test at that moment if the algorithm is good enough, and then go over and over and over this again. So if I have to now wrap all of this in one thing, because I am coming now to an end with this lecture, because it's already about 25 minutes of just me speaking, really. I can do this for hours. The most important things are for us as humans, first of all, to know what are we giving the algorithm as data to train on, what to expect as an output, how will that output look like. Then we need to define the network, to define the model, the algorithm that connects the two, and then we need to train it. And in this training, in the individual steps of the training, what it does is that each iteration, it adjusts and becomes better and better with recognizing the things. So yeah, just to see what's here. Oh yeah, after all, we need to have results, right? Okay. we defined input, output, we defined the network, we trained it, and so on. And then we need to see how well our model actually performs. So I have given you a few instances of applying models. For example, if we talk about images and image classification, we can have binary classification. What you see here is that we have an image and the output is dog or not dog. We can have classification, which puts what's on the image in different categories and says if it's a dog, a cat, a bus, or a plant here. And then we can have also like detection of different parts of the image. So you see how we have a dog, but we also have a plant. And these are different types of input and output. But we can also have predictions and forecasts of time series. So here we have something that changes with time, with months. And what you see here in blue is what the network was trained on. And what you see here in orange is the prediction. So in the end, when you do all of this, we want to analyze the performance and see how well it did. And also, what is kind of my part, explain what led to that decision being made. So with that, this is my side of this little lecture. So if you want to take over for a while I drink some water, and let's see what terms did we understand and what we did not.
Sure. So we'll get to the what's it called? The word cloud. And yeah, here's a slide to remind you of the word cloud, but you have the link in the chat, and I see a number of you have been adding to it, which is great to see. So we'll just pull that up on the shared screen. So we can see in bigger, and we can even go and float over it and see the frequency of some of the ones like machine learning. I saw that was growing big near the beginning because you mentioned that a lot. Data came up throughout. Neural network was really big, but I think there were people who had different, like neural networks with an S was somewhere else, and then neuron networks. So there were different variations, so it didn't end up as big. But we got a pretty good map of a lot of the things you were saying. Does this seem to reflect what you wanted us to collectively understand?
Yes, in fact, I'm very happy with what I see, because we have the different terms I mentioned. I'm very happy to see that data is one of the strongest ones, because in the end, computers are as good as what we give them. So data is really the most important thing. And so good. Then we can make our little glossary of all of this. Also in the chat, I see that someone asked if we can send the presentation to the emails. Yes, we will do that with all of the presentations we show.
And you'll even see once we get to the last slide is a link to the slides. So you can take them home and keep reliving it throughout the week.
Yes.
But yeah, that was already planned. And yeah, of course we'll do that.
Mm-hmm. Okay, so now that we have all of these terms, we have prepared a little PowerPoint presentation, which is also for you. And we are going to share this link to in the chat.
Which I have ready on the second laptop to share in the chat here. Okay, yes. So it's now in the chat.
Yes, and what we do is that together, me and you, fill a little glossary of the most important terms. And there are ones that we have already filled in here in the slides. Artificial intelligence, machine learning, neural network model. See, those are actually very predictive of what people wrote in that word cloud.
Yeah, we predicted well.
Yeah, we are a very well-trained neural network.
Well, but also there's two more ones near the bottom which I added while people are adding to it.
Good, thank you very much.
And there's more slides, so we can add more terms if we feel the need to define more terms as well.
Yes. So this is where we invite you to write up anything that you remembered from what I talked about in the previous 25 minutes or so. So feel free to type here in this presentation anything that you took as notes, as anything you remembered, or anything that you want to write a definition of. So we just keep those, and after this session, we will wrap them up a little bit, and yeah, so everyone will have this as a little bit of an, let's say, a glossary into the most important AI terms, and those you can use when you teach. You can use anytime you want. I just someone said that now they understand deep learning, so I'm very happy. Yeah. anything that you found that is good to be written there, anything that you think that is important to be passed to students when we talk about these terms. And so that everyone can use it, I will just very quickly release, I was sure that we are not holding any of the slides for the people to write, because when someone writes somewhere, other people can't write there, you remember?
No, I don't know
Okay.
what you're talking about.
Okay.
Can you explain that?
Just if anyone has problems typing into the individual slides, please tell us in the chat and we will fix that. So yeah, because when we have the different ways that people understood these terms and the different ways that they would convey them to their students, this is also important for us so that we could use that when we teach too. I realized that this was a big amount of information that I gave you in 25 minutes. So while you're typing, I can already see people typing in the slides. While you are typing, if there are any questions about things that I explained, I would be very, very happy to explain once again, or maybe come back to. Also, once again, if there's something that you want me to dive deeper into, also tell me, whether now into the chat, whether by email or so on, because courses on AI and machine learning are developed for and taught for weeks and months and so on. So this was like an attempt to cover this in a very short amount of time. And if someone's interested in something, then definitely tell me, whether now or later. So I can see that people are writing. Oh yes, Zoom, there's an AI companion. Yeah, but we don't know how good that is.
That's true. That's something that'd be worth playing around with to figure out.
That's actually a very good idea for one of the next sessions. We also have to turn on the Zoom AI companion and see how that does the notes, and in the end of the sessions does that.
But also an obvious thing that we'll end up doing with it is trying to break it or trying to force it to make errors so that we'll learn from the errors or the funny output it gives. And that's something you guys will see a little bit more next time when we're talking about language models, how we intentionally make language models not work to show how a language model works.
Yeah. I see that people are typing, so we are going to give a little bit more time for people to complete that. Also, if you want to add something in the chat and have us paste it there, also feel free to do that.
And we talked about the possibility of using breakout rooms to force small groups of people to fill out some of the slides. I think we might be running a bit short on time on that because we want to overview some of the things. So it depends how we want to manage our time, how much more time we want to do, even if we don't get all the slides done. If we get a couple of them, is that enough? Because there's more stuff I want us to cover.
These slides are actually available for everyone already, right? So even if we stop this at some point, we encourage everyone as part of a homework task to share what they understood. And we will also fill them with anything that remains empty. So if anyone took notes, also feel free to share some of these notes on the slides. And yeah, while I'm talking, this gives a little bit more time to fill a few more slides maybe. But yeah, this will be available. And actually, I can see Michael already editing the presentation that we're sharing with a second homework task to finish filling the slides. And once again, it's not homework like for students. I guess we won't write marks on that. But yeah, it will be good and it will be useful for everyone so that we can all share what we know and what we learned about AI. And really have that for the future when we teach and when you teach. So yeah, I already see a new slide added to our presentation that we're presenting at the moment. So let me just see here. Okay, We have in some of the slides things that are filled out. Feel free to even like continue filling this out. Someone said that they want AI to replace them in jobs they don't like so much. For example, school administration. Oh, I want AI to replace me in administration too. But don't
even in
need
today's
help
opening
in
meeting.
I could be AI right now. This is a two-sided thing, AI replacing people in some things, because from the view of administrators, that wouldn't be so nice. So it's quite of an open question, really, and people feel differently about that. Help in teaching, okay, you might not need help in teaching from AI, but you definitely, I think, want to know when your students are using AI, when turning in tasks and so on. Can it make all the timetables for my colleagues? I join into this request to the big AI corporations to please create something that takes off our paperwork from us.
Well, timetabling is an interesting problem. Yeah.
Okay, so I guess this was now enough time, at least for now, to fill the presentation. So once again, you all have the presentation, you have the link to it. Please, I urge you to fill in anything that you understood from what I was speaking about. But now we can move on to other things.
So we don't have that much time left. We have like 20 minutes left, and we want to go over a little bit what to expect in the coming sessions. So you've all received a list of what the sessions will be about. Those of you who were with us for the Scientix webinar last week, you saw a bit of a preview both on us training baby GTP and some of the stuff on both image recognition and discovery space. We'll go over a couple of things about that briefly and then leave you with a homework task for next week.
Yes.
So we're very excited to announce the birth of our baby.
For the third time.
Yeah, I know. But so the story behind this was we were trying to get weird output from Chat GPT.
Yes.
And I was saying, wouldn't it be great if we could train our own one? And so then Kalina came up with one that we can train. And we're going to train it next week on the input from your homework. Hopefully, hopefully enough people do it that we have data to train it on, because the quality of what we get depends on the data set that we have, and so on and so forth. But we won't dwell on this too long, because we'll, get into that a little bit more next time.
So, yeah, what we ask for is that you complete this very small fun task that we will give you at the end, so that we have something to train the model on next time. Yeah.
And just as like a visual on language models, but we're not going to explain it this time, is a probability tree similar to what Kalina was showing, but with probability next text generation. And do we have time to do this because it's fun and it's quick?
Yes, please.
Okay, we have time to do this. So one of the fun things is looking at what a predictive text generator will come up with. And the simplest model for predictive text that you all have access to is just a search bar, and see what it comes up with next. So some of you were when we were looking at my own name and with some things it would say about me. Now we're using AIMLOW, which is the acronym we're using for the course. And I did 2 searches just before we started from what it's saying here live in Bulgaria. And AIMLOW, we get a book, AIMLOW, Quit Often, Expect the Worst and Other Good Advice. Or AIMLOW, Artificial Intelligence. This is an interesting case because Kalina had mentioned short-term memory of algorithms. And short-term memory, if it's predicting just the next word that comes, then it might not look back at the second last word or even the third last word. And here, because there's a heck of a lot more searches people do for artificial intelligence, and not yet many people do for AIMLOW. By the end of the course, we might change a lot of Google outputs. I mean, that kind of happened, not so much with autocomplete, but with search results from my monthly experiment share meetings. Now, in a lot of browsers, that'll be the top thing that comes up. When I started them 3 years ago, like it would never come up when you search it. Even like Michael Gregory experiment share, So we can change the face of the internet. But anyways, just as a fun, quick thing, anyone who feels like it, everyone should feel like it. Open a tab or use your phone, or, you know, whatever. Maybe you're joining the Zoom from your phone, but open a quick search, type AIMLOW, and if something interesting or fun comes up next, type it into the chat for us to see, and then type AIMLOW artificial intelligence, just to see what kind of predictive text we get from a search. So everyone take a moment to do that.
And while people take a moment to do that, I want to make a little remark about something, which would be that predictive text is not necessarily artificial intelligence, because the earlier versions of predictive, aim low, fly high. The earlier ideas and versions of predictive text just used something similar to the word counter I developed. So it just has a big database of many things that people would search, and makes the prediction based on the next word as to how often it is mentioned. But nowadays, models are employed to actually make the search more tailored to you and what you would search. And it depends on region, it depends on what your previous searches have been, and so on. Even like when you accept the cookies in your browser, also that helps train those models for that, and so on. So yeah, I want to just keep the chat in the context of a course or a methodology. Aiming low can encourage students or participants to take the first step. That's very good, actually, because the whole idea of aim low was a funny acronym. But now that I think of it, there's more behind this than just us having fun. We have aim lower.
Well,
aim low, shoot high.
Well, also on the top of acronyms, it's come up that Kalina works at CERN and for the PADME experiment, and particle physicists use a lot of acronyms. And so I started making fun of some of the acronyms when we were coming up with ideas for this. So we kind of had a challenge of coming up with fun acronyms.
That's true, yeah. And you're good at that, so you're the one who came up with it anyway. So yeah, we do have a few answers, but basically aim low, shoot high is quite a frequent one. Aim low, fly high, and so on. Good. Okay.
Maybe we'll move on. I keep reminding you of the time because I don't want to run late. So.
Oh yeah.
Be quick with this, please.
Okay, yes. AI and images. We'll have a whole session on this. And again, the ones who have seen me before might have seen this. But when we talk about images, we can have a number of different instances of talking about artificial intelligence. So we can have image generation, this very, very famous example of this beautiful mountain resembling a lying woman, which is in fact generated by artificial intelligence. And it's actually generated by instances of unsupervised learning with the idea that it can create mountains with any shapes it wants just because it has learned shapes. Then all of you maybe in your phones have image manipulation through AI, which helps your images be less blurred, more detailed, more sharp, and whatever like artificial intelligence is widely used in this. But the more important thing is that we will cover image recognition because it is a way to demonstrate one of the two types of supervised learning: classification and regression. So yeah, going back to the things I explained to you earlier, really. And for the image recognition, we created yet another tool which classifies images. So far it does dogs and cats, but there are also some very fun ideas I won't spoil. You'll have to come to the session about image recognition to see what we have and how we play with this classifier. When we talk about image recognition, it's very interesting to show some of the explainable AI that I said that I worked on, with showing which exactly parts of the images, maybe I have this here more clearly.
Please.
Which exactly parts of the images are used in order for the algorithms to determine what they see on the image. In this case, dogs and cats. And as you see, For the cat, the eyes of the cat are very important for the animal to be identified as such. And for the dog, we have the legs, the tail, and whatever. So yeah, this is what we'll cover in the image recognition part of this course. And we'll actually, again, train it with you and with your input, with your ideas and so on. So that will be very, very fun.
What apps are used for this image recognition?
So this is actually a code that was written in the language Python, and
Yeah.
it uses a library, maybe one of the most famous libraries for that. It's called TensorFlow. So I'm gonna write it in the chat. Let's see, use TensorFlow. Oops, sorry, I didn't type it as I wanted. Okay. Yes, here we go.
Thank you.
Yeah, so for all of you who are interested in coding and can develop code, everything we show is developed using TensorFlow in Python.
And just to take a step back from that, because this image recognizer, like that Kalina's developed, we're going to be using it. And if you're interested in the details of it or coding yourself, then everything will be open and shared with you. But some of you might not be interested in a purpose-made thing like that. And so we'll also share some of the more popular ones that are available for teachers. Like the one that comes to mind, but there's several and I don't remember the other names, but Google Teachable Machine is one. And probably will include an application of that too. We'll see. I'm maybe getting a dirty look. But like for those of you who just want something that's been mass produced and
user-friendly.
Yeah.
My code is not user-friendly. Yeah, but for the ones of you who write code, all of the code for anything we show is absolutely available to everyone. So yeah.
Okay. And I'm quickly going to go over Discovery Space, which they're the ones who hire me as well. But this course is run kind of as part of Discovery Space, which is an EU project that attempts to use artificial intelligence to help drive differentiated learning experiences through individualized pathways. It's going to be the final session of this course as a sort of invitation to get more involved with Discovery Space, to learn some of the learning scenarios we have, and to attend further training that will be happening both online and across Europe. It's not hugely relevant for today's session. Like the course that is kind of priming you for this as well. But like I'll mention, we've got partners across Europe who are developing things. The bottom line, like I mentioned, without a visual, is taking students through an inquiry cycle where they're going through from engagement, hypothesis, experimentation, analysis, and reflection, but following different steps for parts of the way, depending on their learning needs. Yeah, more detail on that to come, but it's an idea that has a lot of potential, and yeah, I'm excited to be sharing it. And this is just to visualize possible pathways for learners, how they could either go through like one specific pathway, jump to a different level, and everyone's kind of getting a learning sequence or a pathway through the learning scenario adapted to their needs at different steps of the way. Now we're drawing to an end, so we're going to leave you with a short bit of homework. And when we looked at the registration form, most of you expressed either a fair bit of interest or a lot of interest in homework tasks and progress quizzes. This one is going to give us some training data for Baby GPT, but also we're interested in knowing a little bit more about yourselves. So it's going to be to write a short biography of yourself, but also to get AI to write a short biography of yourself. Either Chat GPT or any other text generation of your choice. I mean, that's by far the biggest and the one most of you are likely using. But just like other search engines than Google exist, other text generators than text GPT work, use whatever you like. And then there's a form to submit those. So if you do submit them in the form, we'll have a spreadsheet where we can copy and paste and feed it directly into the algorithm. Be ready to go, showing you what kind of outputs we could get with that kind of input data. Oh, and
save the prompts. What we've said here, basically, we're also interested in how exactly you got ChatGPT or whatever to write your biography, whether it asked you questions that you answered, or you provided the information and it synthesized it and so on. So that's what we mean by save the prompts. We have it included in the form, right?
Yeah, in the form as well.
Okay, so this is what we mean by prompts. Just write, what did you ask the AI tool in order to get your biography from it?
And I realized the next slide about homework task 2 to fill. Oh no, it didn't update. I didn't refresh. Perfect. This was the slide I wanted. Yeah, I don't know where I put the other slide.
Yeah.
Okay, but anyways, the idea. One of the most common questions that comes up with teachers is, how do I recognize AI generated text? There's also a whole lot of other questions. What do I do with that? And so on and so forth. But we're going to use that. So one of the ideas is, with your own generated bios, we're going to attempt to have some of you identify what was written by a person, what was written by a text generator. And this came up in part as an idea. There were 2 discussions that came up for this. One was with my boss at the European Physical Society, who's the Secretary General there. And she was saying, at a physics conference, one of the activities they did to look at text generation was for the scientists to ask, and I think it was just GPT, but to get it to write a bio for them. And this was a conference with like reasonably high-level scientists from across Europe. So there were articles that they had written. There were things written about them online. But typically, AI-generated text would attribute more prestigious awards to them. For example, a scientist who had won maybe the local Mulhouse, that's the town in France where the physics society is, like the physicist of the year for like Mulhouse or Haute d'Alsace. When they asked GPT to write about them, they might say that they had won the Nobel Prize. So it was wildly exaggerating the successes of the person. But one of the reasons for that is the training data. There's a lot more articles written about Nobel Prize winners than there are about local prizes. And so when it's generating text based on the most probable thing that goes after physics prize or prize about a scientist, then its training data has been trained on a lot more data on more prestigious prizes. And it was going through this thought process that I realized an article that had been written about me almost a year before. So you see, October 13th, 2023. And that was by the American Physical Society. And I realized the drafts they had sent me must have been written by artificial intelligence. So when we were talking about this course a couple months ago, we were like, okay, how can we detect that? And we were looking at it, and we ended up asking GPT, what is the likelihood that this article was written using the help of artificial intelligence? And it was only 80%. So it wasn't like 99%, but it gave us a lot of key features of how we could spot AI generated text. So that's what's to come next time. And you giving us a bio of yourself that you wrote and that you had AI wrote would be a big part of us being able to actually do that with the usable data set. If I refresh the slides, there would be the other slide, but you don't need a slide to remind you.
To fill out
maybe you need an email to remind you, but to fill out the slides on key terms and glossaries. And that brings us to an end, right?
That brings us to an end, and it brings us to where we started.
Right. That which you might have noticed we had our nicknames on the opening slide. So this was the opening slide we started with. And these nicknames were generated by artificial intelligence.
Yes, in fact, the language model that we will all together be training next time, we trained it on, first of all, one article about Michael, and then we just gave it the prompt.
This specific article.
Yes, by the way. And we just gave it the prompt word Michael and wanted to see what words it will put after his name. So being trained on an article about him, it said Michael Outreach Man. And then we decided to train it on an article written about me. and then prompted my name. So it said Kalina, the one to read encyclopedias, which actually describe us perfectly. And even this very, very primitive AI tool managed to do a good job in describing us. So maybe AI is indeed that powerful as we think it is.